So our topic for today, guys, our topic for today is something known as a sequence detector. You see, even though the thing is, I'm going to share this Word document, but the problem is that the problem is that you will not be able to capture the working on this. All right, you may not be able to capture the working on this. Okay. All right, guys. Okay, so we are doing some work on something known as the sequence detector. And please keep your mic on once again. Please keep your mic on just in case I make a mistake. So you call it out straight away before we go deep into the thing, all right? Okay, so what is a sequence detector? Well, sometimes for security systems or whenever you are transmitting bits, a number of bits, a stream of bits. So you have a stream you have a stream of bits. You have a stream of bits as such. You know, you have, let's say in a USB system, 1 0 1 0 0 1 1 1 1 1 0 1 0 1. All right. So in a USB system, you know, when you connect your USB flash drive onto the computer, or maybe when you are transmitting information over the internet, all right, when you're transmitting information over the internet, you have this particular system where you have a stream of bits, right? You have a stream of bits being transmitted, right? And what a sequence detector does is it identifies a particular combination. So the sequence detector, I'm going to just use short form, all right? Detector identifies a particular combination of bits within the sequence, within the stream. So for example, right? For example, let's say your particular bit pattern was 0, a particular combination, or maybe we can call it pattern, right? Let's say your pattern was PATTERN. Okay, let's say your pattern was 1010, and this particular pattern indicates the start of the data packet, the start of the transmission. We're not doing computing right now, so I don't want to confuse you. So if you have a look over here, let's see, where does the 1010 start? Okay, that's the 1010, right? So that was example 1, right? Okay, so if you have a stream of bits, you also have, in the meantime, if you have that stream of bits, and let's say our pattern was, let's do a pattern which is unusual in number. Let's say if your pattern was 1011. If your pattern was 1011, then let's see. Okay, let's see. If your pattern was 1011, your output, let's say your output is Z. Let's label it as Z, will equal to, so your output stream, okay, let me line it up. Okay, so let me line this up. 1. The first number is a 1, so that's the first bit. And remember, let us see our pattern. So this is the input stream of bits. Let's call this input X. That's the input, which is X. All right. That's the input X, and this is our output Z. Okay, guys, can you see this clearly? Can you see the diagrams clearly? If there's a problem, technical problem, let me know straight away. All right. Okay. All right, guys. Okay. Now, this is the first bit. This is bit number 1. So our output in this particular situation will be a 0, right? This is our output at our first particular instance will be 0 because that's bit number 1. There hasn't been much processing. Now the second bit is 1, 0. Still, remember, we need a pattern of 4 bits we need a pattern of 4 bits in order to, and what is our pattern? What is the pattern which we require, right? We require the pattern to be 1, 0, 1, 1, right? We require the pattern to be 1, 0, 1, 1. So the second bit is 0, therefore our entire system becomes a 1, 0, but we wanted to achieve 1, 0, 1, 1. So we still have not achieved that, right? We still have not achieved that. Okay, now let's look at the third bit. Third bit is a 1. The third bit is a 1. Therefore, we have still 3 bits. It still has not achieved our pattern of 1, 0, 1, 1. So our output will be 0, right? Our output will be 0. Now, let's look at our fourth bit. Our fourth bit, so it's like a window. We're using a window system. Our fourth bit is a 0. Therefore, what do we have? We have 1, 0, 1, 0, and when we match it up against this, that's a pattern of 1, 0, 1, 1. Oh, again, that's not a match. So what output do we have? We have an output of 0. Let's look at the fifth bit. Now, in terms of the fifth bit, we have to look at the 4 previous bits. The 4 previous bits were 0, 1, 0, 1. Is that matching with 1, 0, 1, 1? Absolutely not. Absolutely not. All right. Okay. Now, let's look at the sixth bit over here. 1, 0, 1, 0. Is that a match with 1, 0, 1, 1? No, that is not. All right. So let's look at the 7th bit over here. Okay. 0, 1, 0, 1. We have to take a batch of 4 bits, the last 4 bits. All right. Okay. The last 4 bits, when we look at this last 4 bits, what do we end up with? We end up over here, and we see that in the last 4 bits, we have 0, 1, 0, 1. So again, that's out. Let's look at the next bit. 1, 0, 1, 1. Oh, there we go. 1, 0, 1, 1. That's a match. So our output will give an output of 1 because we've programmed it to give an output of 1. All right. Okay, now next one. Now the next one, that was 1, 0, 1, 1. We were there. The next one, let's look at 0, 1, 1. No, sorry, 0, 1, 1 will not work. So 0, 1, 1 will not work. Let's look at 1, 1, 0. Absolutely not. Right? 1, 1, 0. Absolutely not. 1, 1, 0, 1. Again, sorry, that's out of the competition. 1, 1, 0, 1. Have you done 1, 1, 0, 1? Yeah, okay. 1, 0, 1, 0. No. 0, 1, 0, 1. No. And then the answer goes no. Right? But if you look at how I dealt with it, it's always dealing with this thing in a group of 4 windows, a window of 4 bits. So we always look at the window of 4 bits. By the way, guys, I hope you can see me highlighting this particular I hope you can see me highlighting this particular set of bits as I'm going along. All right, everyone with me so far? So this is what a pattern detector does. A pattern detector, sometimes they call it a sequence detector, right? Okay, so these are interchangeable names. So that was one example. Sometimes the string of bits is the pattern which is to be detected can be 3 bits long. Sometimes the pattern which is to be detected is 4 bits long, sometimes 5 bits long, and sometimes 6 bits long, right? And the list goes on. Okay, so that's a pattern detector, and I'm going to show you how to build a pattern detector. All right, I'm going to show you how to build a pattern detector. Right now, before we move on, guys, I just want to tell you that this is part of sequential logic, that this particular section is part of sequential logic, and that you have what you call in your final exam, one of the questions will be on a pattern detector. All right. Okay. Just to update you, for those of you who did not come in on Monday afternoon session, in Monday afternoon session we had a discussion about the final exam. Originally, the final exam was supposed to be a face-to-face final exam, which was supposed to be a handwritten exam, like a traditional exam. But unfortunately, we will definitely not be able to do that now. The outbreak is not under control. Last year, the outbreak was under control, and we were able to. Fiji was COVID-free, and we were able to have the particular final exam in a face-to-face manner, right? But this year it will be an online exam, and I will be giving you, one of the questions will be a sequence detector. Definitely, it will be. I will definitely give you a sequence detector question. All right. Right. For those of you guys who have just arrived, please make sure that you put your name and student number on that list. All right. So let's do problem number 1, guys. The only way to really learn these sorts of things is to do these problems. Right. I want you to problem 1. All right. Problem 1. Please make sure you. Okay. So. Please make sure you put your name and student number in the chat box, all right? If you haven't done so. Okay, so design a mealy machine, right? Please make sure you know what a mealy machine is. There's 2 types of machines. Firstly, and I'm not writing it down. See, these are certain things I'm not typing, right? So note that certain things during our session, I may not be typing. You need to note down. So a mealy machine is a machine which whereby the output is whereby the output is in the line of the is bonded together with the input line. All right, and I'll show you, because there's a way to look at the state diagrams and all. And in a Moore machine, the output is determined only by the current state, So this is a question: design a mealy machine model. Design a mealy machine model with a state diagram, state table, etc. For the circuit which produces output 1 when the input sequence of of 1 0 0 1 is received. Okay, when the input sequence of 1 0 0 1 is received. All right. Okay, there's a word over here. Overlapping sequences are allowed. What do we mean by this word overlapping? What do we mean by this word overlapping? Well, overlapping means that if you look at, let's come over here again. Let's come and look at example 1. What if in example 2, if we have an example 2, and the pattern was 1 0 1 0, right? So if you look at it over here, this 1 0 1 0, I hope you can see me highlighting, and please have your mic on so that you can guide me straight away if I make a mistake, because I'm not looking at the Google Meet's screen. I'm only looking at the Microsoft Word screen. All right, I can only look at one screen at a time. 1 0 1 0, that'll give you an output of 1 over here. Then if you look at it, that's 1 0 1 0 will again give you an output of 1 over here. Then there's a 1 0 1 0, so you'll have 3 sets of 1s. You'll have 1 0 1 0, you'll get an output of 1 over there, right? Okay, let's see output Z. Okay, so example 2, let me just, okay, so example 2, the output Z, okay. So you'll have a 1 over here, right? Because that's the first one. Then you'll again have another one here. Then you'll again have, so 1 0 1 0, you'll have 1 here. 1 0 1 0, you'll have another 1 here, right? Okay, and what else? What else, guys? Can you see any other patterns? Are you able to assist me and show me any other patterns? Any other possible patterns? Yes, over here. Yeah, okay, so 1 0 1 0, you'll have another pattern over there, right? So this is what you call overlapping. Overlapping means when you can use the inputs from your previous cycle, which has been what do you call already used, you can use it again. All right. Okay. So this is what they use in a this particular pattern detector or sequence detector, right? Is used in serial communication, when your mobile phone transmits, in internet communication, when your mobile phone transmits data and so forth. All right, so that's what the word thing. So let's look at that's what the word overlapping means. All right. So design a milli machine model. Milli machine is the type of machine. You've got 2 types of machine: milli machines and more machines. And I covered that somewhere. By the way, have I covered it already in week 12 lectures? Does anyone recall if I've covered that already? Milli machines and more machines.
Yes. So,
week 11 lectures.
Sorry, which lecture?
Week 11 lecture, sir.
Oh, week 11. All right. So, okay, you guys are familiar with what milli machine is. So basically, we have to design the whole system. Yes, thank you, guys, for helping me out here. The circuit has to produce output 1 when the input sequence of 1 0 0 1 is received. Right? Overlapping sequences are allowed. Okay, so let's do the answer now. Let's do the solution. Okay, and there's a particular process to it. It's not a simple solution. All right. So basically, your input goes in. Okay, your input goes in, and you have your input goes in. So what we will do is I'm going to put that up slightly. Okay. Now, firstly, this is something I usually draw, but it's not really necessary. It's not really necessary that you draw it as well, simply because this is working. This is a table for the working. There's no particular name for the table. It's just a table to determine our working. The true thing is the state diagram. Once you get to the state diagram, so this particular table which I'm drawing over here will assist us in our working. All right. Okay, guys. So let me just give it some tables, names, states. Okay, and I'm not gonna. We may need 3. We may need 4. Who knows, right? We're gonna. That's part of this particular investigation. All right. States. Okay. Then you have something called the receiving input. The receiving input. All right. You have the receiving input. Okay. I'm just going to turn off my face camera here, guys, because okay. All right, guys. Okay, you have the receiving input. So I'll just put my phone on the side. It's taking a bit of space. Okay. All right. You can't see my face, but you should be able to see my. Okay. The receiving input, or another name is past inputs, right? Receiving inputs, or maybe received. Receiving input or past inputs, that's 2 separate names, right? Current possible inputs, and you have got our next state, or sometimes maybe in colloquial words, go to state, right? Which state to go to, right? That's the colloquial name, next state to go to state. And maybe I'll put a thing over here, our together with go to state, and then I'm going to say and output. Let's say output, and then let me label the output as Z. All right, let me label the output as Z. Okay. All right. Output labels: receiving input, past inputs, current possible inputs. Okay. All right. So obviously, we've got a sequence. Our particular sequence which we have to detect is 1001. Right? We have to detect 1001. All right. Okay. Okay. Go to state. Okay. Guys, can you see the table clearly? Are you able to see? I'm always worried about that. That you might not be able. So this table, I don't have a particular name for this table. This is only, I've created this table to make the working neater and for you to understand. And after a while, once you get used to things, you don't really need to draw this table. After a while, you'll see that, hey, that table was only in the beginning stages. All right. Okay. Now, the first point to note over here is, let me just put this point over here. All right. Okay. Now, how many bits are there, guys? So 1001 is 4 bits. 4 bits, right? So because it is 4 bits, there would be 4 stages. 4 stages to detect. Right? Because you can only detect the minimum of 4 stages to detect the pattern. Set? Okay, there's a minimum of 4 stages to detect the pattern. So therefore, I don't know how to put therefore, the triple dot thing. Does anyone know that? Therefore, you would have minimum of 4 stages. Therefore, you would need 4 states, since this is a Mealy machine. This is a Mealy machine. All right. Okay. All right, guys. Okay, let's start off with the first possible input. Right. Let's start off with the first. So there are 4 states. So let's start off with state A. Let's start off with state A. Okay, state A. Now, what are the 2 possible solutions, guys? State A, what's coming in? Because right now, remember, your system is blank. Nothing has come in so far, right? There's nothing which has come in so far, right? So we are entering the first bit. The system is empty. The first bit is supposed to come in. So let's just put an asterisk over here. This is the first bit. I didn't want this to happen. Okay, this is the first bit. Right, this is the first bit. First bit. Okay. What else can we say about here? We can say that system is empty. System is empty. Currently empty. Is currently empty. No stream of bits has been entered in so far, right? So what are the, so these are some notes which I've written on the sideline over here, right? The system is empty. Let me make this larger. Actually, I wanted to use this particular gap over here to insert a particular diagram. All right. Okay. All right. Okay. What are the 2 possible inputs, guys? Well, obviously, only 2 possible bits can come in. Either you have a 0 or you have a 1. Guys, just to note that these are just some notes, right? These are just some notes which I am inserting into the table over here, right? Okay, let me pull this to the side, right? Okay. All right. Now, what are the 2 or past? What are the past? It's saying what are the receiving inputs, or maybe look at this name here, past inputs. There is no past. There is no past. So therefore, there was nothing here. All right. Okay. So the 2 inputs to the 2 possible inputs to come in are current possible inputs are 0 and 1. So it shouldn't have been there. It should have been here. There are 2 possible inputs. All right. So let me just, for the first time, only this insert symbol. I want a tick. Where's the tick? There's a cross. Sorry, guys, just bear with me for 1 second. If you can help me, I'm looking for a tick. Is this a tick? Doesn't look like a nice tick. Symbol, more symbols, special character. Tick. Guys, do you know where tick is? Okay, I'll just use this. That's a square root sign. Okay. And then the other symbol is a cross. All right. Okay. I've got it all wrong. Okay. Okay. Now, current possible inputs which can come onto the stream are, it can either be a 0 or 1. In each of this particular column, it will always be 0 or 1. So let's just show you guys over here. Current possible inputs are 0 or 1. Okay. 0 or 1. 0 or 1, right? And we have to put in the answer. Now, the current possible inputs are 1. Receiving inputs or past inputs, this is the first bit. This is the first bit. System is currently empty. There is no past inputs. So this particular in state A where we're kicking off, it's currently empty. The first bits have just come in. So when the first bits come in, guys, you have 0, which is, does it match our 0, 1, 0, 0, 1? No. The first bit's supposed to be 1, and we have received a 0. If, let's say, the first bit is a 0, so we put a cross. If the first bit is a 1, we're in. So we are confirming that we've got the first bit. Okay, we are confirming that we have the first bit, right? So the sequence over here will be blank, blank. All right, okay. Okay. All right, guys. Now, therefore, if you have a 0, you stay at the first state, right? You stay at the first state. If you have a 1, you move to the next state. So this is where the diagram comes in. Okay, that's where the diagram comes in. Okay, let me just do a diagram, a state diagram. Oh, shit. Okay, let's see. Hey, we needed only 4 states, guys. So let me just show you the 4 states. Okay. So let's call this state A. Let's call this state B. Let's call this state C. Let's call this state D. We only needed 4 states, so we delete that. You've got A, B, C, D. All right. Okay. Okay, and so I'm just neatening things up slightly. So this is our state diagram. This is our state diagram, guys. Okay, that's our state diagram. Okay, and don't worry about the arrows. The arrows are not totally correct yet. So where were we? We were on state A. We were on state A, right? And where do we go to? We will go to, if your possible input is 0, you see there's a cross. So therefore we stay at A. Okay? So this line follows to that line. And what happens here? Split cells. How do we split cells? Table tools. So if your first input is a 0, we can't move forward. We can't move forward because remember, our output has to be a 1. We have to have an output of 1 when we receive all 4 inputs, right? When we receive all 4 inputs. In this case, our first input was a 0, then our state will remain at A, and our output will be, and our output will be 0. Okay, A and 0. I'm using this terminology here, right? A and 0. What if our input was 1? Guys, how do I split this cell? Does anyone know how to split the cell? Come on, guys, help me out so that we can make this faster. No, sorry. Split cells. Does anyone know how to split cells, guys? Okay. Right, never mind. Guys, help me out over here. Okay. Now, if your input is a 1, we have reached the particular situation where if your input is a 1, so we meet this first condition. Remember, look at this top part over here. We meet this first condition, right? If our input is a 1, we meet this top condition, right? Therefore, what do we get? We get a tick over here, and we can progress to the second, phase, right? The second state, right? Which is B, right? Because we said, hey, remember we said there are 4 inputs, so there are 4 inputs, so you can, right? You can have input of B. Okay, right. So we can move to B. But what is your output, guys? What is your output Z? Your output is still 0. Why is it still 0? Well, simply because your output is still 0. Simply because you still haven't achieved 1001. Now let's go to state B now. State B, okay? So now this first line, I want to reflect it over here. Let's do that straight away. I want to reflect that particular scenario over here. Okay. So A goes to B. All right. A goes to B if our input was 1. So let me just insert a text box. All right. Okay. Insert a text box. Okay. Okay. So A goes to B if your input was 1, but your output is 0. If your input was 1 and your output was 0, okay? So this, you guys are probably familiar with, okay, so that's A goes to B. But hey, hang on, there is another particular scenario over here. You have another scenario that A will state, current state is A, and the next state, so this state is current state. Current state is A, and the next state will be A if the input is 0 and the output becomes 0. The current state is A, and if the input is 1, the next state is B, and the output is 0. So that's what we've done. But there's one more to do over here. There's one more to do. Let's look at it. Shapes. Okay, so we draw this. Okay, there we go. Okay, and I want to convert. Okay. Okay. Sorry, guys. Give me a try. Just bear with me. I know I'm becoming a bit frustrating over here. Okay. In that particular scenario, your input was 0 and your output was also your output was also 0. Okay, let's now move to the next stage. This is where things become interesting. Now, obviously, your receiving input in this case, your receiving input is there's only one receiving input, right? Okay, all right, and you have to take the receiving input together with your particular current input, right? 1 0, right? Your past input was 1, right? You take it with 1 0. What do you get? Is that a correct answer? Yes, that is a correct answer, right? Because if you look at the first two inputs, that's 1 0, right? What if you received 1 as your current input? Then your current set would become 1 1. So maybe we can type 1 over here, right? So 1, you team that up with 1. So this 1 comes from here. This 1 in B comes from here. So if your current input is 1 and your if your previous input was 1 and your current input is 0, you are in. You can go to the next stage. And if your current input is 1 and if your previous input was 1 and your current input is also 1, then no, because you don't have a 1 1 in your particular sequence. So put that there. Okay. So what happens over here, guys, if you have a 1 1? That's why I wanted to split this table actually. Wait, let me split it this way. Okay. Right there. There we are. Okay, what happens over here, guys? Well, you've got a tick, so you go from B to, where do you go to? You go to C, right? You go to B, from B to C. And over here, because you've got a 1 1, what do we consider about 1 1, guys? Well, the only place we can go back is to A. But over here, your outputs are still 0 because you still not have achieved your particular 1 0 0 1. Okay. Now let's look at the third one. All right, let's look at the third one. Okay. Okay, and you have your particular input C. Your current state is C. All right. Okay. Let's now deal with what happened over here. Let's now deal with whatever happened over here. All right. Okay. So B, you're in B, and if your input was a 0, you then went to C. If your input was a 0, if your input was a 0, you went to C, but your output will still remain 0, right? Okay, what if your input was a 1? If your input was a 1, right? If your input was a 1, well, what happens if your input was a 1? If your input was a 1, what is your destination, guys? If your input was a 1, you can stay at B, right? You can stay at B. This was incorrect. You can stay at B because you can restart from there, right? 1 means that you can still continue and restart for a future input, because there's a possibility that after the second one, you might get a 1001 again. So you can stay at B. All right. Okay. Okay. If your input was a 1. All right, I'll explain more about this later. How did we go from B to B? Let's just continue and finish this table up, and then we can further look at it. All right. Okay, let's look at C now. Now for C, our receiving inputs are 1 from there, 0 from here. So you have 1, 0, right? So 1, 0, right? Okay, and the two possible inputs are 0 and 1. All right. Now, if you receive a 0, good. If you receive a 1, that will make the current possible combination 1, 0, 1. If you receive a 0, you become 1, 0, 0. And if you look at it over here, you've got a 1, 0, 0. So you're still in. You're still in. And if you have, if you receive the current input as 1, you get a 1, 0, 1. So you're out. Okay? So now, if you receive this, what do we go to, guys? We will go to the next stage. The moment you get a tick, you can go to the next stage, right? But we still have not achieved our particular 1001. We can only get the output to equal to 1. We can only get the output to equal to 1 once we receive the 1001. All right, now we have D. All right, so we just getting the D ready over there. Now, and what happens if you get a 1 over here? Well, if you receive a 1, you can go back to B. Why do we go back to B if we receive a 1? Well, because the idea, the first part was already correct, right? You already received a 1. So B assumes that our receiving or our past inputs, have already got a 1. Okay? With B, in state B, the assumption is that we already have 1 in the system. So if you have a B, you can then say, hey, we're going to state B, if you have a 1. All right, so that's B and 0. Okay, let's now reflect that. So whenever you do a line over here in our working, right, whenever you do a line in our working, you can always go back to that place, okay? Right, now let's do C. So how did we go from C to D? Well, from C to D, you have to receive a 0 again. To go from C to D, to go from C into D, you have to receive a 0, and the output is a 0. There we go. So that's how I've put that there. And what happens when you receive a 1 in C? If you receive a 1 on C, you go to, where do you go to? You go to B. So let's just draw a line over here. Draw a line. Okay, let me just insert this thing here. All right, there we go. Okay, now let's look at the next line. So we've taken A into account, B into account. It's not a clean thing. Okay. All right. Okay. Now, we've taken B into account. If you receive a 0, you stay at A. If you receive a 1, you go to B. If you receive a 1, you stay at B. If you get a 0, you go to C. If you receive a 1 at C, you go to B. And if you receive a 0, you go to D. Because remember, we are targeting 1001. Now, in D, our three values which are already in the system, loaded onto the system, is 1, 0, 0. All right. And if you receive a 0 this time, then will become 1,000,000. Well, if you receive 1,000,000, then you're out. And if you receive a 1, there your final sequence becomes a 1001, because you have to look at past inputs together with current input to read the current set. The current set becomes 1001. So you're finally in. So if you received a 0, if you received a 0 at D, if you receive a 0 at C, at D, you get 1,000,000. So therefore, the only place that 0,000,000 can go to is A, and your output is 0. And the only place where 1001 goes is it gives an output of 1. We know that. We finally have an output of 1. We already know that part. But what else does it give us? Well, it gives us this particular thing that you've got a 1. And where was 1 loaded before? Well, the only place that 1 was available before was B. So it lights up. At least you get this 1 here, but you go to B. So let's now just complete our state diagram. Okay, so if you have a input of 1, you get if you have an input of 0, then nothing happens, right? And if you have an input of 1, let me just insert the arrow over here. Okay. There we go, guys. This is our state diagram. That is our state diagram. All right. This here is our state diagram. Once we get the state diagram, then we should now consider drawing up the state table. All right. Then we should consider the state table. And let me show you that. Let's move to the next section, which is drawing up the state table. Guys, any questions so far? Any particular questions you have for me before we move on to the state? After this stage here, the hardest stage is drawing this diagram. In fact, after a while, after doing a particular set of problems, you don't need the table. This is a table which I'm only drawing for you in order to show that to show how to do the working, but or to give you some further insight and understanding. But you don't need per se. You don't need to draw this particular table. You can jump straight into this state diagram. All right, you can jump straight into that state diagram, guys. We'll try and do 2 problems today, but let's see if you guys are comfortable with this. Are you guys all right? Have you understood what I've done over here? Okay, maybe you can have a look at the video again. And there's not only mine. If you don't like my video, there's always lots of videos which are available on YouTube and so forth. All right. Okay. Now we have to draw the state table. Okay, we have to draw the state table. State table we draw from this. Now you don't need to look at the question anymore. You don't need to look at this table anymore. It's all based on the state diagram. Maybe I should put a title over here. Okay. Okay. This is the state this is the state diagram. Okay, this is the state diagram, guys. Okay, now let's talk about the state table. Now, state table is taken from what? State table is taken from the particular the state table is taken from the state diagram. We don't need to look at the previous table or the questions anymore. The moment you hit the state diagram, you're good to go. Okay. All right. Let's look at the state table. State table. In the state table, this is going to be downhill from here for us. Not too much effort. All right. Okay. All right. So you have present state. Right. You have next state. Okay. You have output. Okay, and we consider your x equals 0. You consider x equals 0. I'll correct that shortly. X equals 1. And your output with x equals 0 and x equals 1. Let's now roll this in. Okay. Okay. So let's just give that a shade to show that that's our title bar. All right. Your four states are A, B, C, and D. All right. Okay. Now, guys. Okay. Now, guys. Can you guys show me? Can you guys assist me over here? All right, output, and your output is Z. Okay, let's have a look from here. If A is 0, if the input is 0, right? Input is 0. What does it go to? It stays at A. And what is the output, guys, in that particular scenario? The output is 0, right? In fact, we know already that the only time the output turns 1 is if you get 1001, and 1001 only occurs 1001 only occurs when you have D, when you have an input of 1, then you have an output of 1. So if x is 1, so therefore we know that that is the only place where you're going to get a 1. But let's continue anyway. So if input is 1 for current state A, what is the next state? If input is 1 for the current state, so you get B, right? And what is the output? Output is 0. Right. I'm just wondering if I can, just bear with me, guys. If I can move this. Oh, sorry. Just 1 second, guys. Nope. I was trying to put that beside it. Okay, if the current input is B, right? And I mean, if your current state is now B and your input is 1, where do we go to? We go to B, yeah? Okay. We stay at B. And if you have input of 0, we go to C, right? So basically, I'm just transcribing the state diagram onto the table. If your input is, if your current state is B, and your input is 1, your output is 0. And if your input was 0, you go to C, but your output will still be 0. So we know that there's 0. For C, let's look at C. If your input is 1, you go to B, and your output is 0. And if it's 0, you go to D, and your output is 0. So you have D, and again B, and both scenarios is 0. Now, if you are at D, this is the catch, please. If you are at D and your input is 1, you go to B, right? And if your input is 0, you go to A. And if your output, if your input is 1, your output is 1. If your input is 1, your output is 1. And if your input is 0, you go to 0. So that's your state table, guys. That's your state table. From your state table, you can come up with something, the next table called the transition table. Right? So I think you guys have done some examples on this. This is where it all starts to become familiar, because it's you know, once you reach the state diagram, from the state diagram, everything is just like how you've done for your own thing. All right. So let's. I'm gonna go through the whole process with you guys. Not gonna abandon you. Okay. For the transition table, let's now look at it. So you have your input. Sorry. You have your input. You have your present state. You have your next state. And you have your flip-flop inputs. Okay, so let me just add some more things over here. Flip-flop inputs. Okay, you have your output. You have your output, which is we said it is going to be okay. Let's choose what flip-flop do you want to choose, guys? Let's choose the D flip-flop. I'll say let's choose the D flip-flop. Let's choose the D flip-flop. Let's choose the D flip-flop for the design. What else? What else can we say, guys? Number 1 and number 2. There are 4 states. 4 states. Therefore, what is the number of bits required to accommodate 4 states is equal to 2 bits, right? 2 bits require 2 flip-flops. 2 bits require 2 flip-flops. All right, so let's now do what does A stand for? Well, we can say that A is 0, 0, right? This is assignment now. This is the assignment state assignment. Okay, let me just put this vertical separator over here. What does B stand for? B should be, let's say B can be 0, 1. C, what does T stand for? We can have that as 1, 0. And what does D stand for? D can be 1, 1. All right, okay, so these are some notes. We are choosing the D flip-flop. There are 4 states. Maybe we should have done that. Okay, all right. What else about the D flip-flop, guys? Let me just pick up the D flip-flop. Hang on just a second. Let me just, from our Moodle shell. One second, guys. Okay, flip-flop inputs. Okay, let's just merge that. Okay. 1 second. 1 second, guys. I just want to pick up the D flip-flop table, what we have. Okay, I've given the 2018 final exam paper. D. All right, D. Okay, let me just. Okay, I'm just pasting the thing here. D flip-flop tables. There we go, guys. So I just wanted to put the D flip-flop table right on top of us. All right, okay. All right, so that's the output Z. Okay, input. What is our input, guys? Our input would be X. Our input is X. What is our present state? We can say Q1. Our present state would be Q1, Q0. What is our next state? That is our Q1 star, Q0 star, our flip-flop inputs. So obviously, how many flip-flops do we need, guys? We need, how many flip-flops do we need? We need 2 by D flip-flops, right? We need 2 by D flip-flops, so we can have that as D0, D1 and D0. Okay, let's shade that up. All right, guys. Okay. There we are. Okay, set. Let's populate this table here by looking at this earlier table called the state table, right? Okay, so A, what is A, guys? A is 0, 0. A is 0, sorry, 0, 0. Hey, but what we've learned so far is we can do this assignment table simply by plugging in the values 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. All right. Okay. Now, so we've plugged in that side of the equation. Let's now look at the next states. And hey, if you really want, what you could do is you can put a note over here as to what's the current state. Now 0, 0 is A, right? And if your input is 0, what do we get? If your input is 0, what do we get? We move to A. Present state A, the next state will be A. So 0, 0. So this is where I need your help, guys. Help me out over here. And what is our output over here in this case? Output is, input is 0, output will be 0. Okay. Now, 0, 1. 0, 1 was what? B. 0, 1 was B. If our current state is B, right? And our input is 0. 0, 1. If our current state was B and our input was 0, we jump to C. And what is C, guys? C is 1, 0. And what is our output over here in this case? Our output is, because our input was 0, your output will be a 0. All right. Now, let's now do the other ones. Let's again, input is 0. Your current state is 1, 0. 1, 0 was C. 1, 0 was C. And your input was 0. You go to where? You go to D. What is D? 1, 1. 1, 1. All right. And what is your output? Your output is 0. Your output is 0. Guys, are you with me? Help me out over here. If you are, tell me. Just help me out so that we can move this thing faster. All right. If your input is 0, and your current state is 1, 1. 1, 1. What was 1, 1? 1, 1 was D. Right. So 1, 1. Input is 0. You get in A, and your input was 0. What do you get? You get a 0. So you get a 0 over there. And where do you go from D? You go back to A. A was what? 0, 0. All right. Okay. Now, if input is 1, do you notice that no matter what, if your input is 1, all your possible next states are B, which is 0, 1. So we just type 0, 1. 0, 0, 1. 0, 1, 0, 1. And yeah, and if you get a 1 in this particular scenario, where your current state is D, which is 1, 1, and your input is 1, you get an output of 1. Right? So if you're sitting at D, which is 1, 1, your input is 1, you get an output of 1. All the other states, all the other particular scenarios, you get a scenario of 0. All right, now let's have a look at this. Guys, any questions? Any mistakes I've made or something like that? Are you guys okay? All right. Okay. Now, let's have a look at the flip-flop inputs. Now, we know our current state, we know our present state, and we know our next state. We want to know what are the D flip-flop inputs which will get us there. So we have to match for match, right? So 0, 0 will give you a 0. 0, 1, right? If your current input is 0, your next input is 1, you get the input to be a 1. Your flip-flop input is 1. In fact, the way to do it quickly is, do you notice that the Q star line is the same as the D flip-flop input line, the D line, the flip-flop input line. You see, it's identical. That's why this equation comes in. Q star is equals to D. So we know that, hey, that thing is going to be this, just paste it there, and this is going to be this, paste it there. Okay, that's done. Now, the next step is our Kano maps. I think if you look at it, guys, starting from state table, well, once you got the state diagram, you could have, in fact, on the understanding, just like in your particular project, you have A, B, C, D, E, F, G, H, I, J, and then you look at the highest number. But over here, you look at the number of states, and you have to assign some bits to the state to give it an understanding. So we have the same scenario over here. We have to do our K-maps. So our K-maps. Let's move to our K-maps. So let's do the K-map for D1. Let's do the K-map for D1. All right. 8 possible inputs. Okay, so you have 0, 0, 0, 1, 1, 1, 1, 0. 0, 1. Okay, guys, there's a triangle line over here. I don't know, I've forgotten how to do it. All right, guys. Okay, so let's just give this side the top row. The top row, what do we call it? Let's call it Q1, Q0. Okay. So this line here, going to call it Q1, Q0. Q1, Q0, right? And this column here, that's going to be known as our X column. Okay, right? So that's rather than me banging my head on how to do that oblique line over there, this is how we'll just draw it for the purpose of Microsoft Word. Okay, right. So now help me out over here. Let's populate this Q1, Q0, right? Let's look at these columns over here, right? We've got to draw. What do we have to draw? We have to draw the Kano map for D1, the Kano map for D0, and the Kano map for DZ, right? So there. Let me just paste this twice. Okay, that's Z, that's D0. There we go. All right, guys, help me out over here. Okay, what do we get? For Q1 and Q0, 0, 0, right? We have to basically go through the D1 column, right? We have to go through the D1 column, okay? And you guys probably doing a larger set of problems in your projects. So what do we get? 0, 0, 0, what do we get? Do you get it? 0, 0, 0. What do we get? We get a 0. Right? 0, 0, 0, we get a 0. Now, 0, 0, 1. What do we get for D1, guys? We get a 1. So 0, 0, 1, we get a 1. Can you guys help me out over here? Help me fill this, please. 0, 1, 0. What do we get? We get a 1. 0, 1, 0. We get a 1. 0, 1, 1. What do we get? We get a 0. Okay, can you help me out? What's this row over here?
0,
0,
0, 0, 0.
All zeros.
all zeros. Thanks, thank you. Right, nice, we've got that. Let's do this second one. Second
The
one,
last
guys.
one is the 1. 0, 1, 0 is the 1.
0, 1, 0 is a 1. This one here?
And the rest is 0. Yes.
Okay, nice. Thank you. Thank you.
Last row
Right.
is all 1.
This is all zeros.
So that's all 1.
Oh, last row is all 1.
Yes, sir.
Okay, nice. Thank you. Thank you. All right. Now let's look at Z. Let's look at Z. Let's look at Z. Oh, everything is 0 except for 111, right? Which was expected. 111 is 1. Everything is all 0. Okay, let's do the equations for this. What would be the equations, guys? We would have a loop. We would have a loop here. Why is it no? Sorry, it's not. Guys, I don't know why, but I don't want to waste my time. So we would have a loop here and a single loop here, right? This here would be a long loop. I was able to do the loop last time. I don't know why I'm not able to do the loop this time. Sorry, guys. Okay, the single loop over here, what do we get from the single loop over there?
X bar, Q, 1 bar, Q, 0.
Yes, X bar, Q1 bar,
Q, 0.
Q0. Okay, over here, slightly different scenario. You've got this whole line over there. There'll be just an X, right? Or, and then you've got another 2 which is over there, right? So that's X or Q1, or, and Q0 bar. Okay. Okay, let's have a look at this one, guys. Z is equal to, what do we get? Oh, only 1. I don't know why. Last time I did the lesson, I was able to put the loop around this thing, but I wasn't able to do it this time. Okay. This is what? 111. So that's X and Q1 and Q0. All right. Now, all you do now is you draw, you've got 3 equations. these are your three equations. All right. These are your three equations. And from these equations, you can draw your circuit diagram. I want to do quickly just the first part of another problem, because obviously only one problem is not enough. I want to do another problem. I want to move to problem 2, guys. I want to move to problem 2. And I will only do, if you look at it, guys, if you look at this particular problem which we did just then, once you got to the state diagram, without even knowing what the problem was before that, you should be able to do the state assignment table, the state assignment table, the excitation table, and transition table, and so forth, right? Without any problems, because you've done a much bigger problem in your project, right? The hard part was, what was the hard part? The hard part was, you see, this 2-sentence question was going from this 2-sentence question and translating that into this working. You don't really need this working. You can do it straight into this particular state diagram. That was the hard part. So I want to give you another go. I want to do another problem, slightly different sequence, so that you guys have an idea of what's happening. All right, okay. So let's do another one. Guys, everyone okay with me, or is somebody got a problem? If you want to ask a question, guys, let me just pause for a minute so that you can ask me a question with regards to what we've done so far. Hello?
Hello, sir.
Yes.
Could you explain about how do you get the output from the transition table?
Which part, Tukay?
How did you get 1?
How did I get a 1 over here? Finally, over here.
No, from the
Transition table. How did we get the 1 over here?
Yes, sir.
Oh, okay, that was easy. See, transition table, your transition table is based on top of your state table. Okay, your state table is based on top of your state diagram. So basically, everything over here from your state diagram, to onwards, it's all basically just re-representing. Your state table is a re-representation of a state diagram. That's in diagram form. The same information is put here in state table form. From state table, you go into transition table, and basically what we did was, instead of writing A, B, C, D, what we did was we just assigned it. We said, hey, A will be 0, 0, B will be 0, 1, C will be 0, 1, 0, and D will be 1, 1. Right? So basically we just went ahead and did some transitions over there, right? So your question was, how did we get the 1 over here? Well, okay, let me explain that to you. So if we flip back to this, in fact, some students who get the hang of it, you don't need to stop at this particular point. You can get rid of this particular second intermediate table. This is like a middleman. You don't need it. You can jump from this directly into this. And I think I saw 1 or 2 of you guys who showed you who showed your project to me. Some students have been consulting with me. They've been showing their projects and asking if this. They were very good. They went from this state diagram and jump right into the transition table. All right. So to answer your question, so if your present state is D, remember what is D? D is 1, 1. Right? Remember the code which we have given for D is 1, 1. And your input is x equals 1. If your input is x equals 1, your output, your next state will be a B, and your output will be a 1. Right? So if your input is 1, your current state is D, which is 1, 1. Your next state will be B, which is 0, 1. Right? And your output will be a 1. Does that answer your question, Tukai? Or you are confused? Did I even go to the right place for your question, or you were looking at some other table?
Almost I understand.
Okay, okay. All right. You can always ask me. We'll have some more classes on this later on. Okay. Let's see a new question. I'm just going to do the first state diagram. Right? Design a millimole machine. Same question with same question but different sequence. Let's do a different sequence now. Okay, output should be 1. Output should be 1. And let's say the sequence is 1, 1 0 1 0. All right. Okay. Okay. So let's look at some notes. Some notes, side notes. There are so we're looking at problem 2, guys. 1010 is 4 bits. So minimum number of 4 stages to detect the pattern of 4 bits, right? Therefore you will have 4 states, since this is a milli machine, right? If this was a more machine, then you'd have a different scenario. All right, what else can we say? Okay, so let's look at let's draw up our table. This is just our working table. Okay. So our 4 possible inputs are our possible inputs when we kick off are 0 and 1. And what is our sequence, guys? Our sequence is 1 0 1 0. Now, in the beginning, the past input is 0, system is blank. So, that's why I've put it in red here. And our first number in our sequence is the number 1. So, yes, 1 goes through. But if it is a 0, if you receive a 0, if your input X is a 0, therefore this thing gets rejected. You're still stuck. So where do you go? Well, you stay at A because you have not moved forward. You have not moved forward, and you move to 0, right? And what about 1? If you have 1, you move to the next stage. You can qualify. You qualify into the next stage. So, and why did we give an output of 0, guys? Do you understand why I'm giving an output of 0? Well, the output of 0 is, okay, let's say X. All right, because we have not achieved the 1 0 1 0. We've only achieved the number 1. All right, now let's move to B now. So in B, our past input was, in order to get to B in the first place, our past input would be, right? In order to get to B in the first place, our past input would be 1 right? Our past input would be 1, right? And this is always either a 0 or a 1, right? Okay, let's now, in the meantime, while we are drawing all of this, while we are filling this table up, it is important that we have our states ready, right? So 4 states, not stages, 4 stages, which means 4 states. Okay, so let's go over here. Let's try a cycle. Okay. A, B, C, D. Okay. There we are. Okay. All right. If we have A, we will go to, if our input is 0, where do we go to? We'll stay at A. We'll stay at A. Hopefully, have better luck over here this time. You just copy this thing rather than. All right. There we go. So if we have input of 0, you still stay at A and your output is 0. There we go. That's correct. And if your input is if your input is 1, if your input is 1, you move to state B and your output will be 0. Why is your output 0? Well, simply because you have only received 1 bit. There is only 1 bit currently in your bag, in B now, right? You have only 1 bit in your bag, but you need to have a total of 4 bits, and they've got to be in this particular sequence, 1 0 1 0. All right, now let's move to B. And now in your bag or in your system, you have got 1. Because how did you qualify into B? Because you got 1, right? Okay, now your 2 possible inputs in this state are, in this things are, you can either receive a 0 or a 1 as your next bit, right? Is your current possible bit. If you receive a 0, bang, you qualify into the next stage, right? You qualify into the next stage. Why? Because you have achieved 1 0, then only can you go into the 3rd stage. And you just remember, you need to go into 4 bits, right? But if you receive a 1, well, that's like you're stuck at the same place, right? So if you receive a 1, you'll still stay at B, and you'll still stay, and you'll still have a 0. You may be asking again, hey, I received a 1 0 over here. Well, how come my thing is at 1, right? So, well, let's see this. You can put a tick over there. And that was not moving forward. The tick means you move forward. The cross means you are stuck, right? So now you have a 1, a 0, 1, 0. This is the catch over here now, guys. Okay, let's now reflect. Let's now reflect our system over here. Okay, you are sitting on B. You are sitting on B, right? And I'm just going to finish this state diagram, and the rest is very similar. Okay, you are sitting on B, okay, and you receive a 1. If you're sitting on B, right, you're sitting on state B and you receive a 1, right, you have to stay at B. So let's now do this. Okay, you're sitting on B and you receive a 1, well, you'll stay at the same place. You're sitting on B, you receive a 1, you'll be sitting at the same place. But if you receive a 0, you can move forward. You can move forward. See, sitting on B, you can move forward to C. Right? Okay, you can move forward to C. All right, let's see. Now at C, you've already got 1 0 in the system. And your two possible inputs are 1 and 0. Okay, if you receive a 0, then your current set becomes 1 0 0. If your current set becomes 1 0 0, you're out of the competition, right? You're out of the competition. So therefore, you go back to, where do you go to? You go to A. Okay, A, and obviously your output is 0. And if you receive a 1, oh, that's really good news. If you receive a 1, you do that. You move to D, and you go to 0. All right, so because you've got a 1 0 1 0 1 now, right? Okay, now, so let's now reflect that. So if you're at C and you receive a 1, if you're at C and you receive a, if you're at C and you receive a 1, well, you move to the next step, right? And if you're at C and you receive a 0, if you're at C and you receive a 0, well, if you're at C and you receive a 0, well, I've made a mistake here. This arrow is not correct. If you're at C and you receive a 0, you go to A. So let's just put the A over here. Okay. Okay, if you're at C and you receive a 0, you go to A. Now, let's look at the last one. If you're at D, right? If you're at D, you've already got 1 0 1 in your bag. 1 0 1. You've already got that sitting in your bag, right? And your two possible inputs are either a 0 or a 1. Now, if you receive a 0, all good. That's exactly what we were looking for, because you now have 1 0 1 and another 0. So 1 0 1 0. Finally, we've achieved what we wanted. So if you've received the 1 0 1 0, well, obviously we know our output will be 1, right? Obviously we know our output will be 1, but hey, we can recycle some of that, right? Because 1 0 1 0, you notice the 1 0 part, that part can now be used in C as well, right? When was the last time you had a 1 0 in the bag? Well, this. So we have to be very careful in saying where it will go, right? And if it's a 1 0 1 1, well, the 1 can only go, where do we have a 1 over here? Well, it was B. So Obviously, we don't move forward. We go to B, and our output is a 0. Right? So let's just finish this off. D, if you have 1010, right? If you have 1010, you get a C. You get a C, and okay, your output will obviously be a 1. Your input was a 0, your output will be a 1, right? And if you have a 1, you'll go to B, right? If you have a 1, you will go to B. Let me just move this diamonds over here. Okay. If you have a 1, okay, if you have a 1, your output will be B. That's it, guys. That's your state diagram. That's your state diagram. Right? Once you reach this state, it's downhill from here. It's not, it's basically what you're doing in your project from here. Okay? And in your final exam, we will give you guys a sequence detector. What I'll do is I'll post some good tutorials up. There's so many. If you just type sequence detector in YouTube, you'll find a lot of them. I really apologize. I'm using Microsoft Word here. I don't have a camera. The only camera I have is from my mobile phone. I'll see if, and it would have been easier for me to write this up. Now, guys, there's one step more. You have to do state assignment, exactly like how we did over here. Because there's 4 states, so you say A is 00, B is 01, C is 10, D is 11, and then you can go straight to the assignment table. You don't even need to go to the state table. All right, okay, you can go straight into the assignment table. All right, because from there you start into the design phase. Guys, any questions? If you have any questions, let me know.
So for D,
Yes.
when you get 0, why do you go back to C?
Right. Good question, then. Okay. Right. Firstly, the state has to go somewhere, right? The state has to go somewhere. Now, if you get a 0 in D, firstly, if you in D, we're in state D. Look at this table here. We in state D. We already got 101 in our bag. The moment we get a 0, our output is 1. That part is understood. Why do we have an output as 1? Because we then have finally achieved a combination of 1 0 1 0. Okay. Now, looking at this 1 0 1 0, we have an output of 1. But what can we use this 1 0 1 0 for? What part of this, we have to look at it from the right hand side. What particular portion of it can be recycled? So the key word over here is recycle. I want you to put this word down in your exercise book. What portion can we recycle? So from 1010, let's have a look back on this past inputs. What part can be recycled? Well, obviously we're in D. We have to move forward to another place. Can we use it just as a 1? No, the last input was a 0. No. What about 1 0? Yes, we can. We can use it as a 1 0. So we can come over here. All right. So we have to drive it to another thing, because remember our original thing over here? Let's have a look at this example. 1 0. Let's have a look at this. 1 0 1 0. But then you got 2 sets of 1 0 1 0. Firstly, there was a 1 0 1 0 here. Then there is a 1 0 1 0 here. Yeah? Can you see? There's 2 sets of 1 0 1 0 in the same bit stream. In the bit stream, there's 2 sets of 1 0 0. So you'll get an output of 1 over here. Then this, again, 2 of the last bits from the first detection will be again used with the 2 new bits to get 1 0 1 0. Okay? I hope that answers your question. So that's why we send it to D. So basically, from our current, maybe if you want, you can always put in over here another new column, just to help you guys out. Current set. Our current set will be 0 or 1. Our current set over here will be 1 0. Our current set will be 1 1. Our current set will be 1 0 1. Our current set will be 1 0 0. Our current set will be 1 0 1. Our current set will be 1 0 1 0. Our current set will be 1 0 1 1. Okay, this is my current set. Okay, this is my current set. I'm just going to put this in blue just to show that it's something which I've just, this is just part of my working, all right? Okay, in fact, this whole table is my working. It's just for you to teach you guys. In fact, when I do it, because after a while, you'll just get straight into this table, into this diagram. Okay, now, have a look at this. If you get a 1, if you finally get a 0 over here, you got 1 0 1 0, right? But we know the output is now, finally it's 1. We know that it is 1 now, finally, right? Okay, we know finally the output is 1 and we are happy. But where do we go to? So, because we've got to recycle, the bits keep on coming in. Remember, the bits don't stop. The bits keep on coming in. The bits keep on coming in. Look at this. This is a whole stream of bits. Can you see this whole stream of bits over here? It keeps on coming in. And then, what do we do? What do we do? So, what part of this, looking from the right-hand side? Looking from the right-hand side, the only place where I can place this is, either I can place it at A, where the system is blank, or I can place it over here with C. So it goes to C, because 1 0, the past inputs, it will match with this. That's why part of the question says overlapping sequences are allowed. That's why the question, that's, if overlapping sequences were not allowed, then that would not be used. Does that answer your question?
Yes, sir. Thank you.
Don't worry, I'll cover next week again on Monday. I'll cover more of these problems, and and apart from my own videos, I'll put in the discussion table, I'll put in the discussion forum, I'll put some more YouTube videos which I found to be very nice.